Right, just to bring you up to date with what I've been doing with this JackShaft. We've got it sitting here in the mill, so I quickly knocked up a wee jig to support it. These help centre the two holes that are going to be the slot there, and I'll bring the light onto it. Yeah, that's better. And these allow for a bit of sideways adjustment on it, which will move these like this, and just one clamp up the top here and two. Quite straightforward jig. We've drilled all the mounting holes for the engine in both plates. I drilled these two holes separate on each plate, and then I've aligned the two of them together using 5mm drills, just under 1/4 inch, and we've put a couple of tacks just to hold them together, and basically set them up so that they slip into the holes when I feed the drill down. So we've just got to bore these out now to 20mm and then cut the slot between the two holes and mount these back on the bike and get the JackShaft moving forward. So I just thought I would show you how it's progressing. So that's basically what I do, is I drill out the two holes, mill out a centre section between the two holes, and then mill out the edges, and then take the final cut to get it from the very edge of the 20mm to the very edge of the 20mm here. As you can probably see from this side, there's a small step in that which is by the last machining. I just thought I'd give you a wee shot showing you what I'm doing when I'm doing the milling. It all takes time, but yep, the end result's worth it. Right, to bring you up to speed on what's happening with this Triumph with the JackShaft, I've machined out the two engine mounting, frame mounting brackets and JackShaft mounting brackets. I showed you that on the mill in the previous one. And we've just sort of got it rigged up here. I've done a couple of adjusters which allows this to get pulled and on tension as well, so that it's fairly rigidly attached there. I've just used, this is a taper lock bearing, if the camera will pick that up. It's slightly different from the ones I've been using. This is, I'm not going to be using this one. You can see it's got a woodruff attachment in it. As I say, they call this a taper lock. This section's separate from it and it locks into the outside of the actual sprocket itself. I'm just using this for lining it up. I'm still going to be using these type, which is just the bored ones, and we're going to be machining out the face of this and fitting a bearing in. And it'll be running on a 20mm shaft, which is the same size as the back wheel. These bearings, I think I said earlier on, these are actually bike back wheel bearings, so taking the same sort of load for the sprocket etc on the back wheel and all the loads there, so they're well up to the job. This is just a cheap one for machining out all the different sizes and the mock-up. I think costs £2 or £3 compared with I think about £8 for the FAC bearings, the good quality ones. So what we're going to do now is I've made up these fairly heavy duty 10mm thick engine mounting brackets. Well, I say we'll just call them all-in-one mounting brackets, and basically they're going to sit in at the back there. I've used 3 holes because that will help centre these and keep them much more rigid than just 2 holes. So that's the only reason there's 3 on there. I just decided to sort of go heavy duty, and it's basically the same thickness of material. I'm telling a lie, it's 12mm thick, which is just slightly under ½ inch. So yeah, as you can see there's a slight difference on that, and that's just going to be welded right in at the back on the frame rail here. So you can see here, I've excuse me with the camera, I'm looking what I'm doing rather than focusing on filming. You can see that's going to leave room for the weld and that on here. So that's really my next job, to put these to each side, and it's 10mm bolts that's on there. It's going through there, so there's 6 holding the whole thing together. And this was one of the reasons that I initially braced this box section here, with taking this through here, so that I knew that it was going to be, the jack shaft would be coming off of this area. So we've got that sort of fairly heavy duty there. Okay, can't think of anything else to show you at present, so we'll just carry on building this, and I'll show you some footage as we get going. Right, a few people have asked me what program I use for doing my bikes and various other things. Well, this is it here. It's Corel or Corral Draw, whatever way you want to pronounce it, 3. And going back to this jack shaft, here's some drawings that I've done of the bolt holes for the flange plate that will connect up the 2 sprockets. Now, this program allows you to accurately draw the divisions here. Now, other people will just move. Yeah, the beauty about this program is that with just a click of the mouse wheel you can zoom right in to a massive scale. So you can get right in the action. It's a really versatile and very useful program. So yeah, I would certainly recommend it to anybody. It's not a CAD program, but it's certainly probably the next best thing to it. So here you can see the bar that I've got for doing this jack shaft. This is for making up the flange that will attach onto the sprockets. So it's a bit of 60mm outside diameter, which is about 2 3/8, around about there, 2.5. You'll see the slight difference. This is how it comes out from the saw. You see just a wee rag in the edge there, but it's not 100% square, so we'll just put it into the lathe and face it off. And here, if you can see it from out the reflections, is my tricky drawing of all the sizes. Now we'll stick a still image up for you so that you can copy this. I've also got the coordinates for it as well, for milling out the holes, which is probably useful to you. And so we're going to push on with this now, get it on the lathe and start turning it up, because this is running on a bit now, and we'll see where it goes. So it's an EN3 bar as well, just a type of steel, generally good quality and easy to weld as well. It's not got lead additive like some of the bars, which I think is an EN1. But anyway, right, we'll push on with that. So I finished machining this up, and part of the reason for machining this was I can use this to speed up the process and clamp it to that. And actually I've made these holes the same size as the centre bit, so that'll allow me to centre all the holes and then drill them in a drill rather than having to go through them in the milling machine all the time. So they're a nice tight fit. There's maybe a wee bit of rag in that one, but you get the idea. So we'll push on now. What we've got to do is, so here's a wee jig that I've made up to mount the sprocket on. Basically the idea is I made up a bolt that the sprocket fits over. This is the one I showed you I was machining earlier on, so that's the slots on there. Tighten that up and then put it into the jig and use these holes here as a guide for the centre drill, and that's clamped really tight so it can't move, and it's clamped really tight there, so that just allows me to repeat. So we're about to drill the actual flange, and similarly I've drilled them out to 12mm and bolted on this top guide, and we'll run the centre drill down it, and just this wee fly press vise will work fine. It's got a couple of V's in it, so we'll rattle that out. And just what I was wanting to show you was I've drawn a line down here with the felt tip. Now this is just in case there is any movement. I check this before I separate them, and I'll see if it doesn't line up, then there's clearly been movement, which I don't want. So we'll push on with that. So that's it lined up in the 4-jaw chuck. So what we're actually doing here is we're machining out the face roughly for fitting the bearing in. Excuse me, I've got the music blasting in the background, forgot to put it off. But that's what we're doing here, so I just thought I'd give you a video, wee shot of that in action. But the camera's in my way now, so I'm going to move it out and continue on this. I'll show you it fully roughed out before we start machining it into more accurate sizes for the bearing itself. Right, so that's me finished roughing it out. I've taken it to a depth of around 12mm and a width of about 45.5, I think it's 44.45. So now we'll actually machine it out to the right size. So that's this one finished. For the bearing, it's I've made it at 40.8. So we'll get this one out, get the other one in and push on.